Okay, so today we're going to be turning on and setting up the sorter, or the ARIA. So I've got it here. We've got two computers, two monitors, then the machine. So we're just going to start with turning it on. So just want to make sure the computers are on first. Yep, they popped up. And then the big button for the sorter is back here. There's a green button on top and then a smaller white button below. You want to press the green button because the white button turns on and off the lasers. So we just want to hit the green one. Hopefully you heard it turn on. And check that the white button is on, because if the lasers are off, the machine's not going to work properly and it's not going to set up properly. Been there, done that. So when you hit the green button, just check and make sure that the white button lights up. Okay, so that thing's started up. I'm gonna pull you in closer here. Okay, so I'm gonna open up the software, BD Fax Diva software over here. Okay, and then I'm going to log in to my account. And I'm just going to let the cytometer connect right now. So in the bottom corner, you probably won't be able to see, but in this bottom corner here on the computer screen, it says disconnected. So right now the computer and the cytometer are trying to connect. Sometimes it can take a few minutes. So I'm going to let that warm up. And while I do that, I'm going to go grab some gloves and ethanol down this space. It is a sterile space, even though we have other things in the room that are considered not sterile. We try and keep this as sterile as possible since we're sorting cells that we're putting back into culture. It's important that we try and maintain the sterility of the space. So I will go get gloves. Okay. So I'm going to clean up the space a little just to show you guys. Just to make it how I like it when I sort or work on this machine. So what we're gonna do first is grab some gauze. We're gonna get an ethanol bottle, which is back here. So I'm just gonna spray our gauze. We're gonna go around the desk. I'm going to wipe off the pens that are here, put them in the box because I don't need them right now. We do have some tips over here. So we have, again, filtered, sterile, few and thousand tips. So that's usually for filtering samples. We have some filtered, sterile P10 tips, usually for adding Cytox. And then some filtered, sterile P200 tips, and that's usually for running purities. So I like to set them up over here. I'm going to get some more ethanol. And I'm going to go over the mouse as well. You just have to be careful not to put a ton of pressure on there, so click something. And now we've got this little window on our screen. It says CST mismatch. We always click use CST settings. So we're going to click that guy. Okay, so now the cytometer is connected. I can see over there in that bottom corner. It's connected. And what I'm going to do next is start fluidic startup. And then I'll get back to cleaning. But before I do fluidic startup, I just want to make sure that the sheath tank is full. The waste tank is empty. They are. Okay. And our closed loop nozzle is in. Our open loop nozzle is out. So I'm going to go to cytometer. In the top toolbar here, fluidic startup is the first option down. And then I drag this window to one screen or the other. And so the first one checkpoint says, ensure the air and fluid lines are disconnected from the ethanol tank and connected to the sheath tank. which they are. Sometimes we do an ethanol shutdown, and that tank sits back here on the shelves, but it is connected to the sheath tank, so I'm going to hit done for that. The next checkpoint is ensure that the closed loop nozzle is in the flow cell, and it is. I can see it over here. I'll show you guys what it looks like when I go to put the new nozzle in. So that is. Okay, so now that I've checked off those two, Fluidic Startup is going to start running. It's got a percentage bar at the bottom. It takes almost just about 10 minutes to run this. So in the meantime, I'm gonna get back to my cleaning, get everything in a row. And you should be able to hear it. I don't know if you can hear it right now, but when you're doing this in person, this the Fluidic Startup will start making clicking noises and pressure noises and hissing. That's just going through every process of the Fluidics cart and making sure that everything's functioning properly. So don't worry about that. Go over the keyboard. Again, be careful on the keyboard. You don't want to accidentally hit anything. And then another thing we clean is actually the cytometer itself, because we load samples right here. So I'm going to go over that, open it up, clean that, and then that's our light button right here. Clean that off. And then this is where we have our tubes that we sort into. Okay, so just gonna clean it up. All right, so now that we're done cleaning, we'll put that over there, and we'll take a quick break right now. Normally, you can leave the room while Fluidics is running. So if you're really busy that day or if you're processing a sample, you can come in, start the cytometer, connect the computer, start Fluidics, and then leave and go do something else. It can sit here for a while after it finishes with no issues. So yeah, you have a break here, and we'll come back in a few minutes. Okay, so we're at about 82% now, which means we have about 2 minutes left. So I'm going to get ready for the next few steps. So our nozzle, this white guy in here, is in water overnight. So every time that we're done using the sorter, we take it out, put it in bleach for 5 minutes, and then put it into water for the remainder of time until you start it up again. So this tube is actually labeled nozzle. I don't know if you can see. But I am going to sonicate this guy. And we have a sonicator back here. I'll show you. So we can pop it in here. Hit start, and it does it for 1 minute, and that's all you need is 1 minute. You don't want to sonicate it too much. But what that does is it's literally vibrating particles off of the nozzle, and we want that thing to be as declogged as possible. We don't want any junk on it, any debris, because that's going to mess with our stream in here. So we want that to be debris-free. So we're going to literally shake all of the particles off of it. And then I'll bring you back over here. Our Fluidics just finished. So now it's given us the third step, which is remove the closed loop nozzle from the flow cell assembly. And then we're going to insert the right nozzle that's sonicating right now. And I will show you how I get set up for doing this. I'm going to actually lower that. Push it in. Okay. So I grab a Kim wipe, and I get a pair of tweezers, some DI water, and in this little container back here, we have some sticks and stuff. And some of these sticks are broken off, which is what we want. So we want to find a good one that's been broken off. Something like this. So the end of it is not round, it's more pointy, and that's gonna help us to get our O-ring out. So we need that as well. I'll bring you over here. Okay. So what my system includes is putting a drop or two of DI water on the top of this. I'm actually going to move the sheet a little closer. I'm going to grab our nozzle out of the sonicator, put it in a rack over here. So I'm going to start by getting the O-ring out and getting the closed loop nozzle out, and then I'll prepare the new nozzle. So there's a little black, try and get you a little closer. It's tight here. There's a little black piece right here that the nozzle is tucked behind. We turn that to the left, and the nozzle lifts up, and the closed loop nozzle is attached to this beige cord right here. I don't know if you can see, but this beige cord right here, that guy. So we're gonna pull it out. We'll briefly check the top to see if the O-ring is actually sitting in there, and it's not. So we're just gonna pop it back in one of the seats right up here. There's like 6 different little seats. You can pop it in any of those. Now I'm gonna visually check to see if I can see the O-ring in the back of the flow cell where it should be, and it is. I can see it back there, so we have to get it out now. And the easiest way to get it out is get your wooden stick with a flat edge, get it a little wet, not super wet though. So I put it in water, and then I grab that Kim wipe, and I actually just barely touch it to that Kim wipe, and the Kim wipe takes just enough moisture off of it. And then you go in, it should be sitting on the back top of the flow cell. I got it. This is dangerous. I don't know if you can see, but there's an O-ring right there. Tiny little red O-ring. You have to be very careful. These things will fly off if you hit it the wrong way. So I'm gonna put it in a drop of water. Once you get it in a drop of water, it's stable, it's totally fine. It's gonna stay right there unless you blow the water or wipe it up. So it is good in there. I'm now gonna get our nozzle tube, uncap it, grab my tweezers, and actually, even before then, I need to clean these tweezers off. So I'm gonna grab some ethanol and gauze, wipe these guys off. Okay. So now I've got some clean tweezers. You never know what can be on these things. I've got my nozzle in here, so I'm gonna go in, grab this guy, pop that back in there, grab that same Kim wipe. I'm just gonna set it in there for now. Just kind of wrap it, and dry it off. And if you look around, on the top of this nozzle, there's a little round part. That's where our O-ring is gonna be seated. And there are 2 sides to this. So one side looks like this, one side looks like this. They look exactly the same, except on the top side, it says top, right there. I know you can't see, but it does say top. And it's got some numbers, 85 micron nozzle. And so basically where our O-ring sits, which is right here at the top on the circular indentation, that is where our stream goes through. So when we put this in here, the stream of this machine is shooting through this nozzle. And that's why we have to have a tight suction with that O-ring, is you can get a lot of spillage and a lot of messiness if you don't have a good grip, because that just leaves space for the stream to go left, right, wherever. Okay, so now I'm gonna grab the nozzle with my left hand. I've got it saying top on the top, this upper portion. I'm gonna put that Kim wipe down, grab my stick again. I'm gonna do the same thing. I'm gonna get that O-ring, basically just scoop that O-ring up. And what I do, because I don't want all that moisture on there, that I just stuck it in that water, is I tap it against that Kim wipe again. And that takes most of the moisture off there, keeps the O-ring on. And then I've got the O-ring sitting on top of my stick. I think you can see it right there. I've got it sitting on top, and I've got my nozzle here. So I'm going to turn it over, stabilize myself, and pop it on the nozzle. Where are you? Yeah, there it is. So that's our O-ring sitting right there. I don't know if you can see. Looks stable, looks like it's in the right spot. So I'm going to set my stick down. I'm going to put this in our flow cell. Just gently push it to the back. Don't worry about the O-ring. It's not going to get knocked off or anything because it's not really hitting the top of the flow cell yet. But once you turn this black piece, we're going to turn it back upwards the way it was with the closed loop nozzle. Now the O-ring is situated nicely in there. So I'm going to clean up my mess, my few drops of water that I had here. We'll wipe that up, put the stick back. I'm going to open this door to Narnia where it says deflection plates. You twist the little thing here to open it. This is where our stream will be coming down. So I'm going to go back to the computer now, spin you over here. So we had removed the closed loop nozzle. We did that. And then the last step of fluidic startup is insert the correct nozzle size. We just did that. And so now we're done with fluidic startup and we can turn the stream on. So just real quickly, some of the software side. So I like to set my screen up like this. Again, I'm not sure if I can get you much closer. But over here, all of my experiments. I've got my voltage window here. I've got my cytometer window, my inspector window, and then your stream is this long guy right here. And at the top, there's a red X next to the word stream. To turn the stream on, all you have to do is click that guy, and it's going to turn into a green check mark. So now I'm going to go back and visualize and take a look at, again, I don't think you'll be able to see this, but right here, you can see the stream coming down and hitting directly into the waste drawer. Perfectly centered. It looks great. If something were wrong, it would be maybe spraying, it would be sideways, but this looks great. So we're going to screw that door back on, and I'm going to move you back over here. Okay. Ooh. Okay. So, clean up my mess a little more. Got that Kim White. We're done with that. Tweezers go back here. My stick goes back in its box. Okay, so now we can see our stream right here. All these black dots. It's pretty stable now. When it first started, it was like whooshing and moving and just finding its place. But now it's not moving as much. Just a quick note, once you've got your stream on, you don't want to hit the sheath tank or the tubing connected to the sheath tank. That's going to jostle the stream. So if I even hit this tubing, I think you can see it shaking up and down. So you just want to be careful of your feet placement. You don't want to throw that thing off. So we've got our stream, looks pretty good. I'm going to adjust it just a little with the amplitude. So right now I'm looking at the bottom of the stream window right here. It says amplitude, frequency, drop one, and gap. I'm going to adjust the amplitude and frequency to where I think it should be. It's all a little subjective, but generally your amplitude should be somewhere from 20 to 30, give or take. And then your frequency should be somewhere from like 41 to 43.5, give or take. Everyone has their personal preference, but your amplitude and frequency are just trying to adjust at the same time in order to make your stream somewhere around 3 or 4 drops. So right now, let me see if I can pull you in. Okay, so right now we have 1, 2, 3 drops. And then this bar right here, which is our gap. So this is pretty short stream-wise. We generally want it between 3 and 4 drops, somewhere in between there. And this is pretty, as close to it gets as three, as it gets to 3 drops. In fact, we're even missing some of the top part of this drop here. So I'm gonna adjust it. I'm gonna start with the amplitude at 30, frequency at 42.9, and I'm just gonna move it around a little. Okay, I like that. It's a little big. So now we've got 1, 2, 3, 4, but we've got a little extra after this 4th one up here, which I don't love. I'd like for it to be a little smaller. Okay, so now I've got it a little better. So now we've got 1, 2, 3, and some change up here. We've got a little extra of the next drop. So that's between 3 and 4. Not super close to 3, but not 4-ish. I'd say it's about 3.2, really. My frequency is 42.2. My amplitude is 31.3. So those are both right about within range. But what you really want to pay attention to is drop 1. So you'll notice as you're adjusting your amplitude and your frequency, your drop 1 is going to be changing a lot. And your drop 1 is basically where your gap is. So if we had a 4-drop stream, your bar right here would be lower because you're going to have more drops. That's going to increase your drop 1 to somewhere around like 270, 280. If you had a 3-drop stream and this were up more, your gap here was up more because you had fewer drops, that's going to decrease your drop 1, and it would be around 215. Generally, I like to keep drop 1 between 220 and 280. Really don't like to get towards that outlier area. Right now, my drop 1 is at 240, so really safe spot there. My gap is 9. I'm going to shrink that a little. So adjusting your amplitude will adjust your gap, or this gray bar here. So if you increase it, it's going to get thicker. If you decrease it, it's going to get thinner. And I want to decrease it. Right now my gap's at 9, and we really want our gap to be right around 7. It could float from 6 to 8 really, but should be close to 7. So I'm going to decrease my amplitude just a little, and I've got it floating right around 7, occasionally 8, which looks really good to me. Your stream doesn't have to be perfect at this point. We still have to run CST, we still have to run AccuDrop, so things can change as you continue setting up the sorter, but I'm really happy with the way this looks. Very stable. So yeah, we're gonna go ahead and try and run CST now. Let's go ahead and go up to the cytometer toolbar up here. We'll go to CST. It's about 3/4 of the way down. And it's gonna pull up an entirely separate window. If you can't find it, try and minimize your big window that you just had open. You should be able to see it at the bottom here. So this is our CST screen. Right now it's showing us our baseline was run on June 16th, 2021, about a month ago. Cytometer performance, it says it was passed but is expired. So generally you need to be running this every day. And I think the last time CST was run was Friday. Sorry, let me rephrase. You need to run this every time you run on the ARIA or the sorter. If you're not running on it on a day, you don't have to come in and just run CST. But every time you use it, you should be running CST. And the last time someone used it looks like, yeah, last Friday, I think. So we're going to have to rerun it, which is normal. So I'm going to go ahead and close the hood. You want to be careful with this. You want to be careful with everything, but just gently bring it down. And you want to hear it click into place. So just gently tap it in there. And then I'm going to get the CST beads out of the fridge behind us here. Hopefully there are some. Sometimes you have to make new if there aren't any. But I got some. So we're going to throw that on the vortex. So it says CST and the date. We are using a specific lot number. So whenever we run a new CST, usually someone puts a note here. It says new CST lot. The number is 30381. And that is important because right here on the screen, it says setup beads. lot ID. And if you click this down arrow, there's a lot of different lot numbers here, and you want to be running the right one. So we want 30381. I'm going to vortex that thing again. Make sure to take caps off before you even put the tube on. You don't want to load a tube with the cap on. So we'll set that in there. And then at the top here, there's run and abort. We want to run. So now it's saying load the CST bead tube onto the cytometer. Okay. And now it's going to give us our CST screen. And it's loading our tube, which is all good. So we should see some events here shortly. There's a few steps to the tasks here. So the first one is performing laser setup. Then we have identifying beads. Then we have performing cytometer setup, and then it'll generate the results. So I'll try and point out what each of these should look like as it's going through. Hopefully we don't have any issues with CST today. That would be unfortunate. It's a little slow to start sometimes. Okay, so we have the event rate popping up now. So we should get some events soon, ideally. Okay, so now it's odd that it hasn't given us events yet. That is definitely weird. And it's pulling the tube down, so that's not good. Okay, so it says setup failed, failure to place beads on scale, possible cause, the event rate is too low and the cytometer doesn't respond to PMT voltage change. So to solve this problem, make sure that lasers are on, which I will definitely go check those again. Sample delivery system works properly, each detector is correctly mapped, sample contains the right beads. Okay, so I'm gonna pop this back in the fridge and some quick troubleshooting. So yes, our lasers are on. I'm going to throw some water on. So I'll log out of CST, exit out of that screen. In order to load a tube on the ARIA, which is very different from the LSR, you have to have an experiment open. So I'm going to open one of the recent experiments and just click on something random. And we are missing a toolbar. Where are you? Okay, so there's our acquisition dashboard. So now I'm going to change the flow rate to 2. We're going to go ahead and load some water. In the meantime, I'm going to make some new CST beads. Those ones might have been too dilute. I'm not sure. I don't know who made them, but I'll put them back in the fridge in case someone running CST on the ARIA wants to try and use them. I don't know why it was giving me that problem. Okay, so to make CST beads, I've got a fresh capped sterile flow tube. Put that in right there. I've got a P1000 pipette, and I've got CST beads, and this is lot 30381, which is what we want. So you get the little guy out of there, vortex him a lot. Okay, so it is a little weird that there are no events showing up at all. Even though we're running water, you should be getting some events, some random debris, some stuff in the lines getting cleared out, something like that, which makes me think it's something wrong with the lasers, but I just checked the lasers and they're on. So I don't think there's anything wrong with our CST beads now, so I'm not going to make new. I think there might be something wrong with the laser setup. So I'm going to pop these back in the fridge for now. Okay, so I was just looking for some sample tubes to run, but I don't have any. I'll be right back. All right. Back at it again, 2 days later. So I stopped recording the other day because sort of was being a little weird. And I was like, well, let me pause the recording, figure this out, and then I'll start recording again and explain everything I did, to fix it. However, was not an easy fix. It took about 4 or 5 hours. Couldn't figure out what was wrong. Basically, the lasers didn't seem to be working. Checked the button, but was on. I think what happened was the hood didn't click in all the way. So if your hood doesn't click in all the way, the lasers won't turn on. So I think that fixed that. And then after, I went to put some water on to run just a little bit through the fluidics before running CST again. And in the middle of running that water tube, the stream just like went bonkers, way sideways, didn't make sense, not sure what was happening. And so I turned everything off, tried to clean everything to the best of my ability, resonicated the nozzle. So what happens when the stream like throws a clog or does anything crazy is you have to open this up again, take the nozzle out, take the O-ring out, resonicate the nozzle for another minute, and then try and put it back in, clean the whole cell, a flow cell in the machine, and then try and turn it on again. And every time I tried to turn on the stream again, it would go sideways, like would not be even close to where it should have been. It was spraying, it was just like really bad. Couldn't figure it out at all. I cleaned it so many times. Basically, we ended up calling the BD service line, and I told them what had happened, and they said, well, go ahead and I'll show you guys here. Actually, okay, so this is like the flow cell up here. Our nozzle is sitting right here, a little white nozzle. But basically, to check and see if it's something wrong with the flow cell, I don't know if you can see our streams going right now. You can take the nozzle out, take this black piece out, and just run the stream into the waste drawer and see if there's a blockage in the flow cell or if there's a blockage in your nozzle. And so when I did that, it ran normally, which kind of points to a blockage in the nozzle. And I was like, that's really weird, because we had tried another nozzle. We tried the 100 micron. This is an 85 micron. And I was like, that one didn't work either. So I don't know why this one would work. Or this one, this is an issue with the nozzle, but the other nozzle didn't work. Anyway, we looked at the nozzle under the microscope because you can see in the nozzle the little hole that the stream goes through. You can see that under the scope. And Michael and I figured out that there was a huge piece of junk in our nozzle. And he looked at the other nozzle we were messing with, and there was junk in there too. So we tried a few things. We tried just like pipetting Millie Q water through that hole, like as much as we could, just to try and rinse it out. We sonicated. The BD tech told us we could sonicate for 5 minutes, which typically we limit to like 1 minute. You don't want to sonicate a ton. So we sonicated for a while. We kept trying to rinse it. Like we did everything we could. And eventually it got dislodged and we were able to put it in and the stream was normal, which was insane. But a few things to learn from that is check your nozzle under the scope. You could definitely see a blockage in ours, so you might be able to see a blockage there. Check your flow cell by running the stream without your nozzle and without the black piece that holds it in place. Check and see if your flow cell is even running straight, which ours was. Always check sheath. Always try turning the machine on and off, shutting down the computer. This really wasn't a computer glitch, so I didn't try restarting the computer. But if it were glitching, I would shut everything down, restart the computer, and try to log back in and see if it resolved the problem. But anyway, we ended up spending like 4 or 5 hours on that. So I did not continue recording, but we are back, and it is 2 days later. We are going at it again. So I'm setting up the sorter for Michael right now, one of the grad students in the lab. And I've already done fluidic startup, which I showed you guys 2 days ago. And then I just finished running CST. So we have a report here. You get a little window right there, that says unload the CST feed tube. So I'm going to take that off of here and I'll put that in the fridge. Okay. And then we click OK to that, and it's going to give us a window that says basically the things that passed with warnings. So our baseline is this top line here, completed with warnings. Our cytometer performance today is completed with warnings. So we're going to view the report and see what the warning is. And I'm going to scroll down. Warnings will always be in red. So looks like our only warning here is on our APC channel. It's a little elevated. It's at 11.07. But that's not very bad at all. We usually say, like 15 and below is still a reasonable range. Obviously, if the CST passed, it has 1 warning. So we'll keep an eye on it. I know Michael's panel today has a lot of markers in APC, so we're going to gate really conservatively in order to avoid like any mishaps or anything, any impurities. But yeah, so that looks good. So we've done the first few steps. We did fluidic startup. I sonicated the nozzle. I put the nozzle in, checked visually that the stream looked stable, straight, all good. And then I ran CST. Everything looks good. And now we're going to focus on AccuDrop. So I've logged out of CST, and you get a window that says CST mismatch. Always click use CST settings. And now I'm going to tweak our stream just a little to try and get it as stable as possible. And the way I do that is by messing with frequency and amplitude. And I've actually already got it at a pretty stable place. We're at probably about 3.3 drops here. We've got 1, 2, 3, and then a little bit up top there. Our frequency is 42.2, amplitude is 25. Again, as a reminder, frequency should be, anywhere from 41.5 to 43.5. Amplitude should be somewhere around 20 to 30. You can have numbers outside of both of those ranges. That's totally normal. And I will say, the machine, the sorter, you kind of have to go with the flow on this machine. You can't be stuck to a certain number. You can't be like, I'm going to run the stream today at 43.0, and I'm going to make it work. Because sometimes the sorter wants to run at a 3-drop stream, and sometimes it's more stable at a 4-drop stream. And I think the best idea is to kind of follow the lead, find what's most stable. Don't get so caught up on, well, it doesn't look exactly how it looked yesterday. The big picture is it stable? Yes. Is our drop 1 a good solid number? Yeah, we're at 245. Again, we want that drop 1 to be somewhere between probably about 220 and 270, 275. So that's all good. No issues. The stream looks really good. So I think I'm gonna roll with this for now. So I'm going to prepare for AccuDrop, and in order to do that, we have to turn on Sweet Spot. Sweet Spot button all the way up here, right by our stream check mark. You don't want to hit that guy because that turns the stream off, and that's no fun to then turn it back on and adjust it, and, do all that again. But in order to turn on Sweet Spot, we have to make sure that our drop one and gap values match. So you'll notice on the drop one and gap, there's a number that's given to us that we can't edit, and then there's a number that is in a white box that we can edit. We want those two to match. So the machine is telling us our drop one is at 246. So I'm going to type in 246 to match that. And then our gap, which we want to be right around 6 to 7, our gap is at 7. So I'm going to type in that, and now I'm going to hit Sweet Spot. And it's matching those numbers. And now if the stream does happen to sway a little in one direction or another, it's always going to make adjustments to come back to those two numbers that we've typed in. So if it starts to get a little bigger, it's going to adjust automatically the amplitude and frequency in order to come back close to the drop one in the gap that we've set. So our stream looks good. I'm going to open up our AccuDrop experiment. Unlike CST, this is actually its own experiment, so you have to have it on every account in order to run it. It's easy to get it on your account. You just have to export it and then import it if you don't have it. But I'm going to double click to open that. I'm going to open the specimen, and I'm going to click the plus arrow beside the tube. That gives me the option to put this sort layout here. So I've got the sort layout open, this window over here, and I'm going to highlight the tube, make sure my flow rate is at 1, and then the important thing to check is that your left side stream here value down in this bottom window is set to 24, and the rest are 0. So you just want this inner left one to be at 24. So I'll set that. Again, flow rate is 1. I'm going to grab the tube here. Okay, so we've got our AccuDrop tube. We're going to vortex well. Hood is closed, clicked in. AccuDrop is on. Cap is off. We don't want to load a tube with the cap on. All right, so we're going to load. And then once it gets going, we're going to click sort. And when you click sort, it gives you a window over here. I think you guys can see it right here. It's basically saying, do you want the waste drawer still catching the tube, the stream, or do you want your tubes catching the stream? Which we don't have any tubes in right now, so we want to keep the waste drawer in position. So we're going to click cancel instead of OK. If we're actually sorting, you would hit OK. But we are not sorting anything necessarily. We're sorting into the waste drawer. So we hit cancel. You don't need to record this. We use the same experiment every time. There's no need to record new events. And then now, once we check that our threshold rate is somewhere between 800 and 2,000, I'm at about 1,200. We're going to hit auto delay, a button down here on your 85 micron window. It's in the upper right hand corner. So we hit auto delay, gives us a new window. We're going to drag this over to our other screen. You've got 3 buttons down there: exit, start run, stop run. So we want to start run, and it's going to do its job now. So now we've got 2 little squares popped up on this window right here. We want to get to 100 in the left-hand square. Ultimately, you want the values of the 2 squares to add up to 100, but you want to consistently be able to hit 100 when you're running AccuDrop. And that's a sign that you're sorting at the right drop. So this is taking our drop 1 value and checking the position on the stream to make sure that 100% of these drops are making it to the right place. And it's probably a better explanation online or from an expert, but it's really important for sorting that you have a really solid AccuDrop run. And let's see, we had close to 90 there for a second, and then we lost it. So again, the computer is doing all of this right now, so we don't have to do anything. We're just watching the action. Okay, so we're back up to 96. We hit 100 there for a second, but we really need to have a consistent 100. So hopefully, okay, so it actually ended, and it's telling us to exit or run again, but we never actually hit 100 for more than a little while. So I'm going to start run again because I really want to have it settle around 100. If AccuDrop is off, you could be sorting the wrong drop. So when the machine recognizes a cell that you want to sort into, let's say, the left-hand side tube, if AccuDrop is off, it could accidentally sort the drop right after your cell, and then you're sorting the wrong cells. So you really want this to be a good, clean run. Okay, so it found 100 there for a little while. We're getting a little more stability here. It really likes 36.19 as our drop delay. That's when it seems to be finding 100. Yep. So when it's at 36.19, it's cruising right around 100, 96, 98. So we're going to hit exit. We're going to stop sort, stop acquiring, and unload. You don't need to save the report. All right. So now we are done with AccuDrop. I'm going to put this away. And then I'll go down to an experiment. Just going to pick one of my random experiments to show you. 1 second here. Yeah. Okay. Just going to pick one of my random experiments to show you how I'll test sort. Michael will probably test sort himself just to make sure the tubes are on the right spot. But that's the last step essentially before sorting. So just to review, we've done the fluidic startup. We ran CST. We just did AccuDrop, and it set the drop delay for us there. And now I'm going to test sort, and then you're ready to sort. Keep in mind, if you're phenotyping on the machine, but you're not actually sorting cells, you don't need to run AccuDrop. That's just for sorting. If you're just phenotyping, you can run CST. Make sure the stream is stable, but it doesn't need to be a perfect stream, and you don't need to run AccuDrop, nor do you need to test sort. Again, because you're not actually sorting any cells, you're not getting any cells back, so there's no need for that. So I'm going to show you guys how I test sort. Up a little here. All right. We're going to open that up. I'm going to bring you over here. Try and show you. Woo. All right. So first thing I'm going to grab, actually, back here in this drawer right here, there's a few things, a few different size things, but we need this block here. This is, open it by pressing up. So this is a 4-flow tube sort block here, and then this top goes on it. If you were sorting into 15 mil conicals, you could grab this one, and again, lock the top on it, but we're not doing that today. We just want our 4-flow tubes. So I'm gonna push this down to lock it in place. Now it's on here. But we're not sorting into flow tubes. We're going to sort into Eppendorf tubes. So we need little placeholders here. So in these boxes, we have these little tubes that fit perfectly in here that hold our Eppendorf tubes. So I'm going to put 2 of these in here. And then I'm going to grab 2 Eppendorf tubes with the tops cut off that we use for test sorting. I'm going to pop those right on top of my placeholders in there. So if I were to take this off, you can see this is our little tube and it's holding our Eppendorf in there. We pop it in there. So this is what you would sort into. Obviously, when you're sorting, you'll use sterile Eppendorfs, fill them with a little bit of R10, probably about 300 microliters. But for today, for test sorting, we're just going to use these. We're going to toss them back in the drawer after. So in order to put the sort block in, you really need to be pretty careful because you don't want to at all like shove this sort chamber here. And so these parts right here, these little lips that stick out right there, if you can see, those slide into these little hooks right here. So what I like to do is take it by 2 hands and I place it on and then just gently slide it in. You don't have to push it all the way in. You should be able to feel when it's in place. And then we're going to twist this door, open that up. We can see our stream right now, but I'm going to turn on the test sort here in a second. Before I do that, I need to change these numbers right here on this black screen down here with the little lever bars. So this represents our 4 possible tubes that we can have here. We have a far left, a right, and a far right. But I'm just doing the 2 middle ones, which are left and right. So that's going to be these 2 middle numbers. And I know from experience that usually they're right around 35. So I'm going to put the left at 35 and the right at 35. Leave the far left and the far right at 0 for now. And then at the top of this window, you're going to hit voltage. So you don't want to touch the deflection plates now. I think you saw that red light come on. We're going to hit test sort. And now we're going to hit waste drawer, which I'll do it in a second so you can hear the click. But this is going to move the waste drawer so our stream is now hitting our tubes. So listen to this. There it went. It just went back inside there. And now you just have to visually look, really get on top and see if we're hitting our tubes here. Hold on. All right. So my right one is a little too far to the right. So I'm going to switch it from 35 to 33. That's perfect. So both of our side streams that are going into the tubes are hitting right in the center like this of that tube. You don't want it to be hitting the outer wall. You definitely don't want them too close to each other because then you're more likely to get impurities or other issues. So I like the way this looks. We're going to turn off the test sort, and you do that by going the reverse order of how we turned it on. So we're going to hit waste drawer first. That'll click back out. Then we're going to hit test sort, turn that off, and now we're going to hit voltage, and the red light just went off. So now I'm going to close the door, and now I'm going to grab this guy out. Again, 2 hands, just gently pull it out. And now I'll pull our little tubes out. I don't know if you can see, but we do have some liquid in there. So that's what was sorted into our tubes. And so I'm going to go kind of dump these in the sink because I don't want to put this back in the drawer like it is. All right. So now these go back in the drawer. Sorry, and what I mean is the Eppendorfs go back in the drawer because we won't need those for sorting. Michael's going to have his own catch tubes, but he will need these little booster seats. So I'll put those in here. I'm going to leave the sort block intact, and I'm just going to set it right there so it's ready for him when he wants to put his own Eppendorfs in there. And that is pretty much it. So again, we did started by turning the machine on with the green button back behind there. Let it warm up for a little while. Sterilized our area with some ethanol and gauze. Wiped everything down. And then we ran fluidics with the closed loop nozzle in place while we sonicated our other nozzle. And then we put that nozzle in place. And then after a few mishaps, got it all cleaned up. And then after you get the nozzle in place, you can turn the stream on, make sure the stream stabilizes, and then run CST. CST passed with one warning for us, which works out. Wasn't a bad warning. We'll just keep an eye on it when we go to actually do the sort to make sure nothing looks really abnormal. And then we ran AccuDrop, which again, you only have to run if you're sorting. So we ran AccuDrop through the experiment we have on my account, and then we test sorted to make sure that when we actually go to sort, those two streams are hitting the tubes that we want them to hit. Because if they're not, you're just losing cells on the side of the sort block, which is not what you want. So that is pretty much it on how to set up the sorter. It gets less and less intimidating as you go on, I do promise. Especially once you spend a few hours with it, it becomes less of a beast and more of a beauty. We really love her. So yeah, that's pretty much it. Thanks, guys.